And hi Professor Chen, this is my second video for HW8, and this video is about question 2. This question is, let n be a Poisson process with parameter lambda, that is, the probability n, the number of the random points arriving in the range between t1 to t2, equal to k. And the probability of this circumstance, it should be like this. And now we define a new stochastic process as xt equal to 1 if n is odd in the range between 0 to t. And xt is equal to -1 if n is even in the range between 0 to t. And the first question, we need to find the probability xt equal to 1. And we know that when xt equal to 1, the n is odd in the range between 0 to t. So we can just add the probability of all these circumstances that when n is odd, it means we need to add the probability of n equal to 1 and the probability n equal to 3 and the probability n equal to 5 and so on. And when we add all this, so we can calculate the probability when xt equal to 1. So this is my solution here. The probability n xt equal to 1 is equal to the probability k is even in the range between the 0 to t. So it need to add all the probability of different circumstances here. So finally, I calculate the answer should be like this. So the probability xt equal to 1 equal to this. And the second question, we need to find the ext. And we know that in continuous random variable, the ext should be like this. Should be like this, where the fxt is the joint probability density function. But in this case, the fxt should be a joint probability mass function because this is a discrete random variable. And we've already calculated the pxt equal to 1. And this is part of the joint probability mass function. And the other part, when xt equal to -1, we just need to use 1 to minus the probability xt equal to 1, so we can get that. And so yeah, with probability mass function x equal to 1, it should be like this. And xt equal to -1, it should be like this. We just need to use 1 to minus this part, so we can get this. And based on the definition, finally we calculate the ext equal to the negative e to the minus 2 lambda t. It should be like this. And the third question is, we need to find the rt1 t2. And the rt1 t2 equal to the ext1 multiplied by the xt2. And xt1 is equal to this, where the t equal to t1, which means if n is odd in the range between the 0 to t1, xt1 equal to 1, and xt1 equal to -1 if n is even in the range between the 0 to t1, it should be 1. And based on the definition of this, the rxt should be the ext1 multiplied by the ext2, where it's because the xt only have two different value. So the xt1 multiplied by the xt2 should also have two different circumstances. And so yeah, we need to use 1 to multiply the probability xt1 xt2 equal to 1. It is it is one's corresponding probability, and the other part is we need to use a negative one to multiply its corresponding probability here, and the at the core of this problem, we need to transfer this two different circumstances to the other circumstance which we can calculate. And we know that when xt1 multiplied by xt2 equal to 1, there's only two circumstances. The xt1 equal to 1 and xt2 equal to 1, or the xt1 equal to minus 1 and xt2 equal to the minus 1. And we know that when xt1, xt2 equal to 1, both equal to 1, the n should be both even. And xt1 and xt2 both equal to the negative 1, the n should both n should be the odd. And the difference of these two different n should be even, because the odd number minus odd number is even number, and even number minus even number is also even number. So we can perfectly transfer the first circumstance into this, the probability xt1 multiplied by xt2 equal to 1. We can transfer it as the probability k is even in the range between t1 to t2, and where k is what we have discussed, the n corresponding to xt1 and the n corresponding to the xt2. So the k equal to the n1 minus n2, and we know that the n1 n2 only have two different circumstances to make sure the xt1 multiplied by xt2 equal to 1. And first is both n1 n2 equal to the are odd number. The odd number minus odd number should be an even number. And the second circumstance is both n1 n2 are even number. The even number minus even number equal to the even number. So we perfectly transfer the first circumstance into this, and we can by applying this here, we can easily to calculate the value of this probability. And similarly, the second circumstance, when the probability of xt1 multiplied by xt2 equal to negative 1, it equal to the probability k is odd in the range between the t minus t1. Because when to make sure the xt1 multiplied by xt2 equal to the negative 1, there's only two different circumstances. And first, xt1 equal to the n, the xt1 equal to the minus 1 and xt2 equal to 1, or the xt1 equal to 1 and xt2 equal to minus 1. And in this circumstance, n1 and in first circumstance, xt1 equal to 1, xt2 equal to negative 1, the n1 should be an even number, and the n2 is odd number. And we know that even number minus odd number is odd number. And in second circumstance, when xt1 equal to negative 1 and xt2 equal to 1, the n1 is odd number and the xt2 is even number. We know that the even number minus odd number is also an odd number. So we perfectly transfer this circumstance into this. The probability k is odd in the range between the t1 to t2. So and it also can be calculated by applying this. So finally we calculate the RT1 T2 equal to this, because we need to discuss the two different circumstances when T1 less or equal to the T2, or the T2 less than or equal to the T1. So the different circumstances. Finally the RT1 T2 should be like this, and this is the absolute value of T1 minus T2. And third question is XT SSS, explain your answer. And with with second question, we know that est equal to this. Apparently, it is not a constant, so the st is not a WSS. Even though the RT1 T2 is equal to like this, which is only decided by the tau, where tau equal to T1 minus T2, but the ext is not a constant, so the xt is not a WSS. And that's all. Thank you.